Let's take a look on the computer, and I'm going to show you something really interesting. What you see here on the screen is a rendering of the Srgb color space. And you'll see that it's literally a balloon. And the balloon here is going to hold the pixels that we create. You'll notice that there are different squared patches on this balloon, aren't there? They describe different colors. There's red, green, blue, and there's magenta, cyan, and yellow. And of course, towards the top of the balloon, you'll see that it's white. I'll put a little marker here. That's where the true white goes, and a true black pixel would reside down there. So over here in this blue section, that's where blue pixels would reside. And here comes the green section. If you photograph something that's green, the pixel would reside inside there that's going to be green. Well, this color space, this balloon, if you will, is a marvelous device. It's going to hold all our pixels, and it's going to describe each one of those pixels to the next device. So, if we were to take a picture in the Srgb color space, and those pixels that we use to create those picture is going to be held carefully inside that Srgb color space, that balloon that you just saw, those pixels will be accurately described as far as their tone, meaning are they bright or dark, and their color to the next device. And that next device coming out of your camera is probably going to be your monitor, isn't it? Yeah. And then after your monitor, it's going to go to some sort of printer. Well, the colors are going to be translated value-wise from your camera to your monitor to your printer by the language of Srgb. Well, let me show you what it looks like. Say we were to take a photo, a color photo, nice and vivid. Here's a shot that I did of a famous artist down in New Orleans. You'll see vivid greens, rich blacks, bright whites, skin tones, as well as a bright reddish orange color on his shirt. How would you like to see the pixels of that? You want to? Watch, I'll show you. Here's our spinning Srgb color space. And let's take a look at the pixels of that last photograph. Here they are inside our color space. Isn't that crazy? Look inside there. Those are 17 megapixels, 17 million pixels, all described carefully by the color space of the Srgb. Let me get rid of the color space and let me show you just the pixels. And look, you'll see the color of them. Remember the green wall? There's the green wall. There's the millions of pixels that make up the green wall. Remember our subject's skin tones? There they are right there. Remember the red color of our artist's t-shirt? There it is there. Remember all those dark black pixels? They're right down here. They're all clumped down. Remember the white ones from the wall? Look at that. They're right there, aren't they? Sure, there you go. Millions of pixels, all described by the Srgb color space. And guess what? They're described correctly. Will they make us a great print? Yeah, you know why? Because all the millions of pixels that I created with that image are tucked inside that Srgb balloon. Because every pixel needs to be inside that color space in order for them to be properly described. Well, what happens if the pixels go outside the color space? Uh-oh, those are called out of gamut pixels, and that's a big problem. You know why? Because they're no longer described. Their color description no longer exists. That's a big deal. Why? Well, that causes us problems. Let's take another look here. Say we were to take a look at the computer, and let's look at our Srgb color space. There it is again. Now, what is the color space of our monitor? Well, the monitor that I'm using right here today, this is an Apple laptop, and this is what the color space of the Apple laptop, 17-inch, one of the newer versions of the laptop, look like. This color space was recorded by some of my big i1 color profiling tools to build a very accurate representation of what this monitor can see. Now that color space you'll see is kind of small, isn't it? Yeah. Well, guess what? It's just about the same shape as there's Srgb. Let me make Srgb a little bit transparent. And you'll see on the inside here, there's our monitor space, and on the outside, there is Srgb. You notice there is a little difference there, isn't there? Yeah. Our monitor, even on a $3,000 laptop, has a color space that's smaller than sRGB. It's a problem, isn't it? Yeah. When we send our files to a lab to be printed, guess what? That color space of those printers is a different shape than sRGB, but overall, it's about equal to, if not a little smaller than sRGB as well. Well, hang on a second, then why is there so much trouble with sRGB and Adobe Rgb? Hold on, let me show you. Let's get rid of the color space from our monitor. Here's our sRGB space. Let me bring it back up to its full brightness, and let's compare sRGB with Adobe Rgb. Whoa! Look at how much bigger Adobe Rgb is. I'll make it a little transparent so you can see the difference on your screen. Wow, look at that. Adobe Rgb is lots bigger, isn't it? Oh, heck yeah. It's almost 80% larger in volume than sRGB is. Well, wouldn't a bigger color space be a better color space? It is. It sure is. But here's the problem. Let's say we were to go back and we were to photograph that artist with the big, beautiful colors in the Adobe Rgb space. And I did. Here's the Adobe Rgb Pixels. Wow, look at the pixels are the same number of pixels, but they're spread out in a bigger space, aren't they? Sure. We're filling up that Adobe Rgb space with the the pixels from that picture that have the greens and the reds and the skin tones and the blacks and the whites. Those pixels are pretty awesome, aren't they? Well, here's the problem. Let's say that we don't view this in the Adobe Rgb space, but what if we were to view this on our monitor? Well, you'll find out that if we have all those big Adobe Rgb pixels, they're sticking out. See those pixels hanging out there? Oh, big problem. This is the big issue that we deal with when we have to work in the Adobe Rgb space. We can capture pixels with our cameras that are placed correctly in the Adobe Rgb space. But then when we view those files on our monitors have a much smaller color space. So that means there are pixels floating around that are not described to our monitor. So you know what that means? That means when you're adjusting the color and the contrast and the white balance and all those other things on your Adobe Rgb files on your laptops, you are adjusting pixels that you can't see. So how can you get the feedback on the monitor if you can't see the pixels? How do we solve that problem? Well, it's very simple. This laptop has the ability to run an external monitor, doesn't it? Sure does. Do you know that you can buy a monitor that is Adobe Rgb capable? Sure, we recommend them on Shoot Smarter all the time.